This will be video 5.2. We'll be adding and subtracting decimals. So let's get started. Okay, adding and subtracting decimals. I can add decimals and I can subtract decimals. There's your NS3 standard, fluently add and subtract, multiply and divide multi-digit decimals using the standard algorithm for each operation. I think you're going to find that adding and subtracting decimals is a lot easier than the multiplying and dividing of decimals. Let me minimize myself and we'll get started. So let's model addition with decimals. So you can use grids to model decimal addition. So for example, a chemist combines 1/1700th milliliter of water and 49/100th milliliter of hydrogen peroxide in a beaker. How much total liquid is in the basket? Whenever you see the keyword total, that's an indication you're probably going to add something up. So that is what we are going to do. We're going to add these two decimals. So there, I'm going to circle or highlight or underline my numbers and my problem and my question, which is usually the last sentence in the word problem. So I have 0.17 equals the same as 17 over 100. Why? Because how do I read 0.17? I read 0.17 as 17 hundredths, which is 17 on the top and 100 on the bottom. So there I have a grid of 100 squares and I have colored in, how many do you see there that I've colored in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 are colored in. 17 out of 100, 17 hundredths. The next number is 49 hundredths. How do you think I'd write that as a fraction? Yes, I'd put 49 on the top and 100 on the bottom. So let's color in 49 more squares. So we can count them if we want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And you could keep counting, but there's 49 pink squares colored in. Now we're going to add the two numbers together. So if we were adding fractions, we've done that before, have we not? We've added the top numerator to the other top numerator and gotten an answer. So we know we're pretty familiar with that. And with decimals, we can do the same thing. So 9 and 7 is 16, carry the 1, 4 plus 1 is 5, plus 1 is 6, 0 plus 0 is 0. So 0.66, which is the same as 69 hundredths. So let's see that all colored in on our grid now. There we've combined all of them. So 69 hundredths is the answer. And you'll see that 69 or 66 hundredths is the answer. You'll see that 66 squares are colored in out of 100. Okay, let's do another one like this. Let's add 24 hundredths plus 71 hundredths. Let's model that. So 0.24 is equal to, what is that as a fraction? 24 over 100. So there is 24 squares colored in. You could count them one by one, or you could do this. 10, 20, 21, 22, 23, 24. 24 hundredths. We're going to add 71 hundredths to that. How do we say that as a fraction? Oops, I forgot to change that. 71, and I'll put that 71 there. 71 over 100. And then we color those squares in, and we should have 71 colored in. If you count those, there'll be 71 there. Then we add them together. So 4 plus 1 is 5. 2 plus 7 is 9. 0 plus 0 is 0. 95 hundredths as a fraction is, what's wrong with me? That should be a 5. 95 over 100. And if we see that all colored in, there we are, 95 squares out of 100 colored in. How many are left that are not colored in? 5, right? So that's 95 hundredths. Okay, next page. It's your turn to try adding some decimals and modeling with them. See you back in a moment. Okay, welcome back. Let's continue adding decimals. When adding decimals, there's only one thing to remember. Line up the dot and give it all you got. Okay, and there is our dot. What is the dot? The dot is the decimal. So you know I've got a song for you, right?
Now what in the world is that itty bitty dot? Yo, I just can't remember and it's making me distraught. I saw it in the price of the item I just bought. It's the decimal point. Yeah, now you're getting caught. When you add and subtract them, there must be a rule. So listen to my rhyme and use it as a tool. Just line up the dot and give it all you got. I said line up the dot and give it all you got. And when you take the difference, in other words subtraction, just use the same rule and bring on the action. Just line up the dot and give it all you got. Come on, line up the dot and give it all you got. So turn off the TV, forget the radio station, cause the itty bitty dot is a math sensation. Move it to the right and the number becomes greater, and the itty bitty dot needs no translator. Move it to the left and the number gets smaller. Yes, the itty bitty dot is an academic scholar. So don't forget the rule, which needs no revision, cause the itty bitty dot is on a great big mission.
Line up the dot and give it all you got. Line up the dot and give it all you got.
And thus this concludes the decimal song. With the rapid mathematician, you can't go wrong. Just
Line up the dot and give it all you got. Line up the dot and give it all you got.
Just line up the
Dot and give it all you got.
Come on, line up
The dot and give it all you got.
Just line up the dot and give it all you got. I said line up the dot and give it all you got. Just line up the dot and give it all you got. Come on, line up the dot and give it all you got.
Okay, let's go back to our presentation. I love that song. All right. Where's our next slide? There we go. Okay. Okay, Susan rode her bicycle 3.12 miles on Monday and 4.7 miles on Tuesday. How many miles did she ride in all? Another key word for adding is the word in all. So let's see. So remember to line up the dot and give it all you got. Just line up the dot and give it all you got. So anyways, 3.12 plus 4.7. Notice how we have lined up the dot, the decimal point. Then we add 2 plus nothing is 2, 7 plus 1 is 8, and 4 plus 3 is 7. Notice how the dot is lined up, and I can show you my nice line here. It is lined up. Let me move it over a little bit. Let me undo that. Let me move it over. It's lined up exactly right. So it's all lined up. That's what you got to remember. So the answer is 7.82. That's how many miles she rode in all. Okay, we're going to add this number. We're going to line up the dot and give it all we got. There's our dot lined up. We're going to add 2 plus 7 is 9, 4 plus 2 is 6, 0 plus 0 is 0. Notice how our dot is lined up from top to bottom. The answer is 69 hundredths. Yay. Okay, let's try this one. Line up the dot and give it all you got. Notice how we lined up the dot there. So 5 plus 6 is 11, and we carry the 1. 6 plus 2 is 8, plus 1 is 9. And then 4 plus 3 is 7, 7.91. Okay, you get to try some addition of decimals. See you back in a moment. Welcome back. Let's talk a little bit about eliminating zeros. So some zeros can be added or eliminated in decimals. Let's take a look at what that means. So zeros can be eliminated when they are in front of the decimal or at the end of the decimal without changing the value of the number. We're actually writing equivalent decimal expressions. 5.0060. Is there any zeros we can eliminate? Yeah, we can eliminate the end zero. So 5.0060 is the same as 5.006. Do not, however, eliminate the zeros in between the numbers. You cannot eliminate those zeros. They have to stay there. Let's try another one. Which zeros can we eliminate in this number? Do you see any? Well, we can eliminate the zero in the front, and that zero in the front, and the zero in the back. So that new number is the same as the other number. It's still 3.105. It's the same as 3.1050. However, we do not eliminate the zero in between the numbers. We can't eliminate that zero. That has to stay or we change the whole number. How about this one? What zeros can you eliminate? Did you say that one? Good. Did you say that one? Good. Zeros at the beginning or at the end, right? That aren't sandwiched in between other numbers. So that 700.4 is the same as 700.40. Do not eliminate the two zeros in the middle. Okay. Now let's talk about adding zeros. Some zeros can be added or eliminated in decimals, like we said. So zeros can be added when they are in front of the decimal or at the end of the decimal without changing the value of the number. So 6.2, where could we add a zero? Right there. 6.2 is equal to 6.20. They're equivalent. What about 0.27? We could add a zero where? How about in the front? That doesn't change the number, does it? No. 0.27 is equal to 0.27. What about 7? Where could we add a zero there? Well, we could do 7.0, or we could do 7.00, or we could do 7.0000000000 forever, right? It doesn't change the number. 7 is equal to 7.0, which is also equal to 7.00. Okay. What about 0.77? What if I put a zero right in the middle there? Can I do that? No, you do not add zeros to the in-between numbers. You can't put them in between the numbers. It changes the number because 0.77, that's 77 hundredths, is not equal to 0.707, which is 707 thousandths. They're not the same number. What about here? What if I put a zero right there? Can I do that? No, that's a zero in between two numbers. So we can't add zeros in between numbers. 2.64 is 2 and 64 hundredths. That's not equal to 2.064, which is 2 and 64 thousandths. Okay. Okay, you get to try some of this adding zeros and eliminating zeros questions. See you back in a moment. Okay, welcome back. Let's talk about subtracting decimals now. When subtracting decimals, there's only one thing to remember. You know what's coming, don't you? Line up the dot and give it all you got. Just line up the dot and give it all you got. And you know what's coming next, don't you? I just have to do it again. I have to play it again. Here we go. I'm going to stay on this time. All right. It's going to play. And I think I'm going to dance for this one. Oops. Where'd it go? Play. I know why I can't play it. I got to push the button. Play. Oh, you know why I can't push the button? I got to go exit out for a second and play again. Now it'll work. Fast forward that a little bit. There we go. Okay. All right. You ready? Are you ready? I'm ready. See if we can get it in there.
Now what in the world is that itty bitty dot? Yo, I just can't remember and it's making me distraught. I saw it in the price of the item I just bought. It's the decimal point. Yeah, now you're getting caught. When you add and subtract them, there must be a rule. So listen to my rhyme and use it as a tool. Just line up the dot and give it all you got. I said line up the dot and give it all you got. And when you take the difference, in other words subtraction, just use the same rule and bring on the action. Just line up the dot and give it all you got. Come on, line up the dot and give it all you got. So turn off the TV or get the radio station, cause the itty bitty dot is a math sensation. Moving to the right and the number becomes greater, and the itty bitty dot needs no translator. Move it to the left and the number gets smaller. Yes, the itty bitty dot is an academic scholar. So don't forget the rule, which needs no revision, cause the itty bitty dot is on a great big mission. Line up the dot,
give it all you got. Just line up the dot, give it all you got.
And thus this concludes the decimal song. With the rapid mathematician, you can't go wrong. Just
Line up the dot, give it all you got.
I said line up the dot and give it all you got. Just
Line up the dot,
give it all you got. Come on, line up the dot, give it all you got. Just line up the dot, give it all you got. I said line up the dot and give it all you got. Just line up the dot, give it all you got. Come on, line up the dot and give it all you got.
All right, that was fun. Okay, let's go on. See if I can get back. Next slide. Oh, yeah, hit present. Okay, let's do some subtracting of decimals. May is 160.2 centimeters tall. Chloe is 165.1 centimeters tall. These are some 7th graders this year, aren't they? How much taller is Chloe than May? I don't know if you know them. They kind of look like the 7th graders. If you look at those two 7th graders, you'll see that. Okay. So line up the dot and give it all you got. So let's see. 165.1, that's the bigger number that always goes on top, minus 160.2, and you subtract, there's our dot lined up. We're going to cross off our 5 and make it a 4 because we can't take 2 from 1, right? And then we're going to bring a 1 over here. So 11 minus 2 is 9. 4 minus 0 is 4. 6 minus 6 is 0. And 1 minus 1 is 0. Can we eliminate any zeros? Got our dots lined up nice and neatly. Yeah, we can get rid of that 0. And we can get rid of that 0. So our answer is just 4.9 or 4 9/10. Let's try another one. Okay, remember to line up the dot and give it all you got. So let's see, how do we do this one? Can we take 2 from nothing? Well, we got to put something there. What are we going to put there? A 0. Whenever you have a subtraction problem and you have no number on top, you got to put a 0. So now we can't take 2 from 0, so we have to borrow from the 7. So the 7 is going to become a 6. The 0 is going to become a 10. So now we have 10 minus 2, 8. And now we have 6 minus 1, 5. Now we have 8 minus 6, 2. And then 5 minus 5, 0. Can we eliminate any zeros? Yes, we can. That one right there. And our answer is 2.58. Okay, how about this one? Pause the video, try this one yourself, and then come back and watch me do it. Okay, we're lining up the dot, giving it all we got. And there's our dot. We're going to put a 0 in for the missing number. We're going to borrow from the 2 because 7 is bigger than 0. The 2 becomes a 1. The 0 becomes a 10. 10 minus 7 is 3. We can't take 3 from a 1, so we got to borrow again. So we're borrowing from the 8. We're going to make that a 7. And then this 1 over here is going to become 11. So 11 minus 3 is 8. And now 7 minus 6 is 1. And then 9 minus 1 is 8. That one answer is 81.83. Notice how the dot is lined up straight down the entire way. So that is lined up. So when you do these, make sure you keep a nice even columns with your numbers. And you could use graph paper to help you. That'd be a great thing to do to keep your decimals lined up. Okay, you get to try some subtraction problems. See you back in a moment. Welcome back. So now let's focus on some higher order thinking. How do we do this problem? 9 minus 2.307. Which number goes on top? Which number is bigger? Well, of course, 9 is bigger. So we're going to put 9 on top. And notice how I put a bunch of zeros after the 9. I have no decimal, do I, right here? So you can always assume there's an imaginary decimal right after a whole number. Okay, you can always assume that. So that's why I assumed the decimal was right here. And then this 2.307, I'm lining up my decimal points here. And I have to fill in with zeros, right? I have to put some zeros in there because I didn't have any numbers above 307. Okay, so now let's subtract. So I can't take a 7 from a 0. So I have to borrow from here. Uh-oh, I can't borrow from here. So I have to borrow from here, but I can't borrow from here. So I'm going to go way over to the first number I can borrow from, which is the 9. And I'm going to borrow from it. I'm going to make it an 8. Now, this is the thing. When you've got a lot of zeros next to each other, this is the rule. The end 0 becomes 10, and all the other zeros next to it become 9s. Now we can do our problem. 10 minus 7 is 3. 9 minus 0 is 9. And 9 minus 3 is 6. And 8 minus 2 is 6. And where's my decimal go? Right there. It has to line up with this column right here. Okay, my decimal has to line up there. So this is a 9, 6.93 or 6.693. So let's bring our answer in. 6.693. I feel like we should try one more of those. So let's do 7 minus 3.612. Notice how I have to put my decimal point with my whole number, and I have to put 3 zeros on top of my other numbers, and then I can subtract. So I can't take 2 from 0, and I can't take it from the other 0, so I have to come over here and borrow from the 7 and make it a 6. The end 0 becomes a 10, and all the other zeros next to it become 9s. So 10 minus 2 is 8. 9 minus 1 is 8. 9 minus 6 is 3. And then 6 minus 3 is 3. So that answer is 3.388, or 3 388 thousandths. I thought we should do one more of those. Okay, now it's your turn to try one of these kind of problems, and then I'll see you back. Okay, welcome back. Now it's time to say goodbye. Our homework for lesson 5.2 is on Google Classroom, and I will see you guys next time. Bye.